Welcome, boys and girls, to a short video on how to sample from a population. General outline. First, we're going to define sample versus population. Briefly, what we mean by inference. What is sampling bias? How do we conduct a simple random sample? And maybe some other sources of bias. So, a population includes all individuals or objects that we're interested in learning about. For instance, our population might be all men over the age of 18 in the United States. And perhaps we want to learn what's the average height of all of the men in the United States over 18. That height for all men is called a parameter. It's a numeric summary of the population. Now, we can't possibly measure every single man in the United States and then average all their heights. So we take a sample, hopefully a representative sample, and from that sample, we calculate a numeric summary called a statistic. And then we take that sample and the statistic that we got from that sample, and we try to infer something about the entire population. From my sample of men, is it possible to infer the real height of all men in this country? And the question really becomes well, it depends. It depends on how you picked your sample. Is your sample representative? So the big picture. You start off with your population, all men. And we say, hey, I want to know their average height. So we take a sample, hopefully a really representative sample. And from there, we try to infer back to the entire population what the height of a man over 18 would be. Look at these headlines. Dewey defeats Truman. Did that happen? No. Question mark. The paper that you just saw was published before the 1948 presidential election was concluded and was based on the results of a very large telephone poll which showed Dewey sweeping Truman. But you never really saw President Dewey, did you? It was Harry S. Truman. What went wrong? Even though the sample was, in this case, they said a very large phone survey, the issue came with this that their sample wasn't representative. I just want you to think about who owned phones in the 1940s. That'll give you a really big hint of what went wrong. So sampling bias occurs when the method of selecting a sample causes the sample to differ from the population in some relevant way. If a sampling bias exists, we cannot trust the generalizations to the population. I think that just pretty much repeats what we just said. So here, let's take a look. Here's your population. We sample. If it's representative, we smile and we can generalize. If it's not representative, we're going to frown because we might end up with biased inferences. Goal: select a sample that is similar to the population, but smaller. And this is our miracle cure to how to avoid bias, and that is to use random sampling. Wow, I kind of gave that away before the drum roll. Please forgive me, boys and girls. Imagine putting all of the names of all of the people in our population that we want to learn about into a hat and randomly selecting from that hat. This is kind of like when I do the homework lottery, when I give each of you a number, and then I randomly select a number, and that's the person who wins and gets to put their homework up. We like this idea of randomness because it gives us an intrinsic feeling that things are fair. Okay, a lot of times also we do this with technology, and I just gave away that punchline because I said I used my calculator. So here's kind of the strength of random sampling. Go back to 2008. Gallup poll took a random sample of 2,847 Americans. 52% sampled supported Obama. Now think, out of all America, is that really a large sample? Not really. The actual election had 53 supporting Obama. Pretty powerful stuff, because if they chose a let's just put it this way, their sample was representative, they were able to make very accurate inferences. Here's another example. Now, imagine you were looking at the Gettysburg Address, and I said to you, I want you to pick out 10 words that you think have lengths that are really representative of the entire Gettysburg Address. And then I want you to take the lengths of those 10 words and average them. And then let's say I had the entire class put their averages on the board. So if you look right here, this X bar right there means that one person picked out 10 words visually, took their lengths and averaged them and graphed that and said, maybe that's an estimate of the true length of the words in the Gettysburg Address. Now, if you go to the bottom, instead of having people eye it and kind of choose what they think is typical, because we're very biased, and a lot of times our eyes are kind of, I guess want to say, focused on the larger words that we miss the littler words or smaller words. So what we can do instead is give every word in the Gettysburg Address a unique number. And then I can go random int 1 through 10 on my calculator and take 10 unique numbers, and those numbers will correspond to 10 words in the Gettysburg Address. And then I average those lengths. So if I look at this X bar over here, you'll notice that it's a little bit over 5. But the idea here is that the 10 words I averaged were chosen randomly. Now, take a look at this top distribution. Do you notice how it's kind of centered at higher numbers? I'd say looking at this, the average was somewhere between 5 and 6. But by doing it randomly and looking at the bottom distribution, we can see the average is somewhere between 4 and 5. And amazingly enough, the real value is 4.3. It seems that by going with a random sample and averaging the lengths of 10 words chosen randomly, those means are centered closer to the real value. So random versus non-random. Random samples have averages that are centered around the correct number. Non-random samples may suffer from sampling bias, and averages may not be centered around the correct number. So for example, when I did a non-random sample and I took lots of samples, my average was centered closer to 6 because my eyes focused on the larger words. When I randomly sampled, picking words using a random number generator, my numbers were centered, or my means, closer to 4, which is the real value. So that kind of puts everything in perspective. And you can't see this jumbled out, but only random samples can be trusted to make generalizations about the population. Okay, next up, let's take a look at the famous bowl of soup analogy. So I want you to think about tasting a yummy bowl of soup. The soup is my population. It's the entire bowl. But I want to sample a little bit to make sure it's really good. So I take a spoon and I take a sample. That's the part that you're tasting. Now let's just say I'm worried that the soup is maybe too bland. So I decide to put salt in the soup. If I put the salt in the soup and I don't stir it, and I take a little sample, I might take it from the top and then it'll be too salty. But if I stir the soup, which is kind of like randomizing it, and then I take a spoonful out, it's going to be more representative of the entire bowl of soup. So with that said, you don't want to take non-random bits. You want to really stir it up, and take a really good spoonful of the soup so that you get a really representative sample. You don't have to eat very much to know if it's good or if it's bad. Now, what I'd like to just focus on briefly now is a simple random sample. By definition, every group of the same size has the same chance of being selected, regardless of other units chosen. The best example of this is to think of hats. Hats, huh? Let's say I wanted to pick 5 of you to win a all-expense-paid vacation to Bermuda. I put everyone's name in the class in a hat. I shake the hat so it's random, and I pick 5 names out. Every group of 5 has the same likelihood of being chosen. I could also do this using technology. For example, I could give everyone in the class a number from, say, like 1 to 30, and then take my calculator and use the random int command and say generate 5 numbers. I would keep generating numbers until I had 5 unique numbers, because I wouldn't want to send the same person on the trip twice. So this is called a simple random sample. That is probably the best method of sampling. Now, there's lots of bad methods of sampling. For example, you could sample using, how do they put this here? Based on something obviously related to the variables you're studying. For example, I want to know how much kids study, so I poll kids as they walk into the library. Don't think so. Who's going to the library? Are the kids who don't study going to be in the library? Today's poll on fitnessmagazine.com asked, have you ever hired a personal trainer? Well, who's going to fitnessmagazine.com? If you're not fit, do you think you're at that site? Again, not representative samples. So under bad methods of sampling, we also say, let your sample be comprised of whoever you choose to participate. What they mean here is voluntary bias. Okay. People who choose to participate or respond are probably not representative of the entire population. Think about when they say, call into a radio show if you think Elvis is alive. Yeah, the people volunteering to call in really feel strongly. Okay, I'm going to kind of skip over this for a second because we're running out of time, and mention some other forms of bias. Because even when we choose randomly, we can get bias. For example, and I'm going to skip ahead a little bit. Question wording. A random sample was asked. Should there be a tax cut, or should money be used to fund new government programs? Wow, 40% said the programs. More said the tax cut. Same question. Should there be a tax cut, or should money be spent on programs for education, the environment, healthcare, and crime fighting and military defense? Wow, now you're going to see 78% have supported. So even if the sample was selected randomly, we would still have bias because of the wording. Context. Ann Landers asked her readers if they'd have kids again. The question was embodied in a letter where parents wrote in that had a lot of issues with their kids. So only 30% responded yes. Newsday did it completely randomly. Same kind of survey, would you have kids again? And 91% yes. So summary, you want to take a simple random sample or some sort of random sample to guarantee that you have a representative sample, but you can still introduce bias if your question is not worded correctly, or if you have volunteers or even people who are convenient to you. Hope this helps. On Answer the Worksheet, make sure that if you have questions, you come see me in class.